Hi everyone. So today I'm gonna talk about chapter 6, introduction statistic. In this chapter we're gonna talk about modeling random event and the normals and binomial models. Maybe we don't want to talk about the binomial models. Um, the major three is we're going to talk about section 6.1 and 6.2. So in this chapter, I'm going to talk about probability distribution, which are the models of random experiments. Okay, so in this section 6.1, we're going to talk about what is probability distribution, distinguish between discrete and continuous random variable, using probability distribution to compute probabilities. So let's go. Okay, so probability distributions. Okay, let's have a table or graph that tell. It is a table or graph that tells first all the possible outcome of a random experiment. Second, the probability of each outcome. Okay, and now let's do a table that have an experiment that's rolling a die. Okay, so you understand that a die is like a cube that have I forgot how to maybe like this, how to draw it. No, I think it's hard to draw, but just gonna have a cube like this. Okay. Yeah, and X side in here you have like some number, for example, from 1 to 6, right? So in here I have 4. Here's 1, 2, and then another 1. Okay, so now all of the X in here is talk about the outcome, right? So the first one is only outcome for number 1, and the second is for number 2, number 3, number 4, number 5, and number 6 down here. So and the second row, second column is talk about the probability of each outcome in here. For example, to get number 1 after rolling a dice, you get like 1 out of 6. Okay, so similarly number 2, because you have only one number 2, so that's going to be also is 1 out of 6, and 3 going to be 1 out of 6, and so on, right? So that is the reason why we have probabilities of each outcome in here to be 1 out of 6. Now the question is, what is probability of rolling a 5 or a 6? So you should know that the word or that make you think about the additional rule, right? So firstly, this these event are independent event. They are not having any um, effect for each time you roll dice, right? So if you still remember from the session 5.3 or something like that. for the additional rule in here is also these um, event, they are also mutually exclusive. So you should uh, you should have as probability of 5 or 6 will be equal to probability of 5 adding with the probability of 6, right? So you can apply the general rule that you can subtract for the probability of 5 and 6, but because you know that this one is mutually exclusive, so you should have p and p of 5 and 6 should be equal to 0. So let me just equal 0 here, right? So then now you can easily know that probability of 5 or 6 will be equal to probability of 5 plus probability of 6, and that will be equal to 1 out of 6 where the 5, okay, plus with 1 out of 6, right? Then you should have the answer at probability of 5 or 6 will be equal to 2 out of 6, which means 1 out of 3. Okay, so that's the answer. Now let's move to the next one. Okay, next one. So now let's talk about two types of numerical variables. So you learned from chapter 1 about discrete numerical and continuous numerical. So both of them are from numerical variables. So discrete or continuous. Okay. However, the discrete numerical value that you can list or count, so such as 1, 2, 3, 4, 5, something like that, right? So 1, 2, 3, 4, 5, something like that. Let's do an example. Let's have some examples such as number of siblings, number of songs, or a number of songs on an MP3 player, and for number 2, continuous outcome cannot be listed or counted because they occur over a range of value. So again, it cannot be listed or counted, right? So example is like the height of the basketball player, the wage of a sandwich, something like that, right? So let's move to the next one. Okay. Label each the value a variable as decrease or continuous. So firstly, number of car owned by a household. So it should be discrete because well, it should have like 1 car, 2 car, 3 car, or 0 car, but you don't want to have like 1/2 of car or something like that, right? Okay. Okay. So next one, number of pairs owned by student also is to be decreased because you could have like 0, 1, 2, 3 pairs, but you don't want to have like 0.5 or 1.2 something like that. So, you know, so that's we discrete. Okay, now for the time it take to a worker to commute to a job site. So as I would say, it is a continuous because you know time it could be like 5 hour and 1 minute, you know, or and 20 seconds, something like that. So it's not be the whole um like a whole number that we can count it easily. So this should be continuous for the time. And now let's have the height of the building. Any any variable that's measuring about high wage time, then it should be continuous. Okay, so the height of the building in downtown San Jose, it should be continuous. Okay, anything else? No. Okay, now we have two feature of probability distribution. Okay, first one, all p of x values must be between 0 and 1. I mean, this one is obviously, okay, that's probability is always from 0 to 1. You cannot have less than 0 and greater than 1, okay? Remember that. Or in notation, you have like p of x less than equal to 0 and less than equal to 1 and greater than equal to 0. And the second one is the one that you must remember for this is sum of all probability of x values must equal to 1. So the notation should be like sum of px I will be equal to 1. So that is about this. Next one. We're gonna creating a probability distribution. Suppose you roll a fair six-sided die. You win $10. If you roll a 5 or a 6, you lose $5. If you roll 1. For any other outcome, you win or lose nothing. Okay. So we'll create a table showing the probability distribution for the amount of money. Okay, so now the x will be what? The amount of money you win, right? And the p of x is going to be the probability of each case in here, right? So all right, so first case, you will be win $10. So I'm gonna say $10, right? Because this is like amount of money you win. The second case is you lose $5. So lose, so I could put minus $5, right? And the last case is you win or lose nothing. So put 0, right? Okay, so now let's talk about the probability of each case in here. You should understand that for the case of $10 in here, let's put a note here. You should know that if you have 5 or 6, right? 5 or 6. When you roll a die and get 5 or 6, that means the probability of that will be, according to the previous example, will be 1/2 plus 1, sorry, 1/6 plus 1/6, which is equal to 2/6, and which is equal to 1/3. But I mean, I will just gonna keep 2/6 because later on I can do for the other easier. All right. So now let's come back with the -5. -5, if you roll number 1, so that means what? You got only 1K. I mean, only number 1 that make you lose $5. Okay. So to get number 1, what's the probability of that? It should be 1 out of 6, right? Because there is 6 outcome totally, and you want only number 1, so that means 1 out of 6 gonna be probability of that. And last case, you're gonna lose $5. So, and for any other outcome, we mean what? 2, 3, 4. So that's gonna be what? 3 out of 6. But actually, if you don't want to see this, right, you can just take 1. You minus for 2 out of 6, and you minus for 1 out of 6. Then you also gonna have 3 out of 6. Yeah. So I mean that is many way, but I just gonna show you that you can do either way and get to 3 out of 6 for the case that you win or lose nothing. Okay. So if you try to adding all these stuff, so you have 2 out of 6 plus 1 out of 6 plus 3 out of 6. It should be equal to 1. See that? So that should be probability distribution. Okay, it satisfies what satisfy all the 2 features of the probability distribution. So we're gonna move to the next page to see what they do for this problem. Okay, this is actually my solution, but you can see how they did. Okay, so let me clear this. Okay, so here's the explain from the notes. There are 3 possible outcomes: win $10, lose $5, or win lose nothing. X going to be equal to 10, -5, or 0. The probability of rolling 5 or 6 and winning is, so like I said, 2 out of 6. Or is the probability of rolling 1 that losing $5 is going to be 1 out of 6. Okay, so and then the lastly, nothing, we're gonna be 2, 3, or 4. That's gonna be 3 out of 6. So that's is explanation, and now is a table that they need. This is exactly what I just did for you guys. X is all the amount money that you win for this game, right? First is you lose $5. That probability gonna be 1 out of 6. You lose nothing, so 3 out of 6. and you win $10, you're gonna have the probability gonna be 2 out of 6. So note that all probabilities all probability of x values are between 0 and 1. See that? This one is less than 1, greater than 0, less than 1, greater than 0, less than 1, greater than 0. So, and when you adding all of them, it should be equal to 1, right? So 1 out of 6 plus 3 out of 6 plus 4, 2 out of 6, that equal to 1. So that's satisfied, right? Okay, so now let's see what is the next line gonna be. Probability distribution for continuous random variables. Because you cannot list all outcome for a continuous random variable, we cannot represent the probability distribution using a table. Graphs called probability distribution called probability density curves are used instead. Okay, so let's see. So they want to use a graph, and we call probability density curves. Okay, here we are. So here is the example for the probability density curve. These probability density curves show the probability of wait time before service at a coffee shop. And the shaded area represent the probability of a waited between 0 and 2 minutes. So you see that between 0 and 2 minutes, it is here, and it look like I'm gonna say almost one half. So maybe I don't know, maybe 45%, something like that, of 45% the whole area, or it's gonna be like 0.45, something like that, approximately. Okay. And the total area under the curve is 1. So so how can I say for this one? It's like probability to let me clean this up. Probability that you have to wait from 0 to 2 is about like 0.45 or 45%. Okay. So now let's talk about finding probability of the uniform distribution. So this is uniform distribution. The uniform distribution is have like exactly one shape, like a rectangular, something like this. So a bus arrives at a certain stop every 12 minutes. The graph shows the probability distribution for wait time before the bus arrives. Use the distribution to find the probability of a wait time between 4 and 10 minutes. So I'm gonna estimate here is 4 and 4 to 10, right? Okay, so I'm gonna shade it all the area in between under the curve in between 4 and 10. Okay. Okay, so now I actually make a rectangle with one side is from 4 to 10. What is distance from 4 to 10? I know that this has to be 10 minus 4 is 6, right? And the other side is to be what? The same as from 0 to 0.08333. So I put 0.08333, right? So if you see you want to find the area of the rectangle that have information of two sides, you should know that the area should be equal to base times height, or yeah, side by side, right? I mean, so base in here is 6 and height in here is 0.08333. So what is that gonna be? 6 times 0.08333 is gonna be 0.49%. So 0.49998. Yeah. So that should be the poverty that X is in between 4 and 10. Let me clean this up and write it more clear. Four to 10, right? Okay, so that should be the answer. And now we go ahead and see what is not explained to you guys. Okay. Oh. All right. So the shaded area represent the poverty wait time in between 4 and 10. Okay, same with me. We can find the area of this rectangle, length times height. Okay, instead of using the word base times height, and they use the length times height. That's okay too. So 6 times 0.08233 gonna be equal to 0.49998, which approximately equal to 0.5. Okay, cool. Same thing. Now let's finding area under the curves. In general, finding area under the curve that are not geometric shapes like rectangles is difficult and requires using some type of computer-based technology. I will I will talk more about that later, but we're gonna stop this section now, and I'm gonna see you in 6.2.